So I'm starting a little bit early, this will be fine. I'll make sure I speak very quickly. Today we're going to talk about how we optimize your Unity code with Synopsys. My name is John Jacott. I'm actually Director of Software Security Solutions for the Software Integrity Group of Synopsys. Today we're going to actually cover very quickly an intro and the background. We're going to talk about why security quality tested, and then of course our solution itself. Mainly this is going to be a test of English comprehension. I'm kidding, there's actually going to be a translator that will kick in a minute. But a little bit about me. I'm a former intelligence analyst. What that means is I used to actually hack applications for a variety of sovereign nation states to find information actually about a variety of different assets and people. I have a master's in business administration specializing in IT security from the Haas School of Business, which is actually in California in the United States. And as mentioned, I'm the Director of Security Solutions actually for Synopsys. Synopsys is very happy to actually be a sponsor today with Unity, and we look forward to a continuing business relationship actually with Unity and hopefully with yourselves. So what we really want to talk about, and translation's going well, what we really want to talk about is what exactly software liability is, because it's an emerging market. It's actually things that are changing very, very rapidly. Back in the day when we had standalone software security applications, we only cared if that application fell down. If that application fell down, hopefully it came back up in a secure state, but that's a quality issue. No one actually made money from Windows doing a blue screen of death. Then what happened actually is we get later in the day, we now have Jeeps and other vehicles actually driving around with software built in them. The average automobile, for instance, has more than 100 million lines of code actually built into it. A jetliner actually has one. What does that mean to us actually as gamers and game developers? Well, gaming is actually right in the middle of the software quality and security war. If you were to go talk to Sony about how they actually built in bad SSL licensing and people were able to take the Sony network off the internet for 4 months plus, that cost Sony $600 million and then some. So imagine if you were that developer and you could actually go to Sony and say, I'd save you that money. I'm going to develop a better gaming solution that has security and quality actually built into it that's going to cost you less money. Imagine what you could do actually as you start to develop that. That's what we're going to talk about today, is how to mitigate that software liability and exactly what that software liability is. So as we start to develop these applications, people are saying, we need this application yesterday. This game is 3 weeks late and it's costing us money every single time. You may actually be developing a gaming platform with continuous integration, meaning that it's every day that you do a release. You may actually have to worry about increased agility, getting that thing out faster and faster and faster. And then what happens actually when it comes down? What happens when there's actually a problem? Your online gaming platform just suddenly stopped working. What do you do? We also have to deal with applications that are generated from a variety of different places. When I build an application now, I don't start from scratch. I go and grab a module that works well for us. You have to deal with open source types of issues. You have to deal with taking existing functionality, existing applications from other sources and putting those together. And you know what happens? If that application is breached, or if it falls down, it's my problem. It's your problem. It's now your name actually on that issue. And of course, we have to actually get down to the fact that we don't really have a lot of time in the organization to get all of this stuff right. They don't actually pay us to make non-buggy code. They pay us to get the code out the door as fast as we possibly can. So we talk about that organizational inertia. It starts from the top. So what does a mature game development process look like? You have a variety of technologies that are actually built in to your process. You may be using static analysis today. It may be open source. It might be Covariance. You may be using software composition analysis. You want to look at what is in that application before you take responsibility for it. You may want to actually look at malformed input testing, which some people know as fuzzing. You might use open source fuzzers. You might actually be using Synopsys' own fuzzer. You might even have interactive application security testing or automated test optimization. But these are the technologies that actually a mature process will use and that you'll have access to to help you fix defects as you write them. And we'll talk about that process a little bit more. But you might actually have a methodology that talks about a secure development lifecycle integration. And I'm sorry if I'm already putting the crowd to sleep. I may actually get up and walk around amongst you to make sure you're staying awake on me. You may actually have workflow automation. You may talk about third-party certification. Somebody may come in and actually test your application to make sure that it's appropriate. You may actually talk about internal policy enforcement. You might have a team that actually looks at your application and says, you know what, here's a vulnerability that we have to fix before you go live. You may have international standards compliance. Actually, the US government or the Korean government may actually take a look at your applications to make sure that you're not risking in a Korean branded business. And then lastly, your people, your biggest asset, may help you do a security assessment. They might help you actually fix vulnerabilities within your code. They might actually work on a secure software development lifecycle. A variety of different things where people, process, and technology can help you avoid creating games that have security defects. And some of you are probably wondering why I really care about security in a game. Well, we'll talk about that. Because when you start looking at actually the risks and the threats that a game actually brings to the table, they're really quite big. If you have a distributed or heterogeneous client, that means actually applications that have been out there for a very long time. You might actually have the traditional exploit. People may actually be able to do a buffer overflow or SQL injection against your application. That's actually really pretty bad because you're putting your application out there for 99% of the attackers to take advantage of it. Very few sophisticated attacks against these. You might actually talk about a multiplayer networked environment. Talk about Sony PlayStation, for instance. I don't mean to keep beating on them. There's Xbox. There's a variety of different network and multiplayer systems like World of Warcraft, actually by Blizzard. You talk about hacked accounts. The average World of Warcraft hacked account actually sells for $750 on the US market. It takes actually Blizzard 6 months to get one of those accounts back. And at that time, people are actually losing a lot of different personal information. The average credit account actually through like TransUnion, Equifax, Experian, your credit card information is worth about $900 on the open market. And people are able to actually pull this information down from a networked game. And we'll talk about how we get to that in a little bit. In-application purchases. How many of you actually develop freeware games that actually bring in revenue streams by actually doing in-application purchases? You want to go play Angry Birds, you can buy different types of birds and different types of attacks in that game. That means I get access actually to credit cards. And I can pull down credit card information if I can breach Angry Birds, for instance. And I might be able to get all of your credit card information. So this is why this matters. Hacking games is big business. It's actually worth a lot of money. So what are we missing here? We talked actually about a secure process, we talked about people, we talked about technology. What we're really missing is a sign-off capability. Literally the ability to, as you develop code, know what you're supposed to actually develop against. You need to actually be able to do quality and security together. When you have release criteria, you need to understand what that means technically. So release criteria for quality might be no buffer overflows, no unsigned integers. It has to actually compile correctly. It has to work within your IDE, and it has to actually stand up and work well as a game. You might have agile feature acceptance. We're going to develop Angry Birds 1 this week, and on Wednesday of next week, we're going to actually develop Angry Birds the Bomb Edition, and that'll be released actually very quickly. You might actually understand what is required for a successful build, and you'd be surprised how little people know that. You might actually know what's required for code check-in. But what we're looking at is that as you go through every single gate of product release, feature readiness, compile and build, you get to a code check-in phase so that you minimize rework. As you actually buy applications, and that could also mean open source, you understand what the open source legal requirements are for that particular application. You know regulatory compliance, what you can do with that application, whether you can export it actually to different countries. You know in an industry compliance perspective if that actually meets your industry requirements for like Apple to go on an iOS device. Or best practices compliance because you know that we should not embed bad SSL certificates into your platform. And when you get to that sign-off stage, you understand what it is that you're trying to do as you develop this application. It sounds really kind of simple, but when we start talking about technical controls for this, it gets kind of complicated. So when we talk about quality and security, generally speaking, we've had different processes for a quality issue versus a security issue. And what we're here to tell you is that it can be the same process. That quality actually looks for functional correctness of an application. Security looks for the exact opposite. Security is, can I cause your application to do something it is not supposed to? When we do testing, you can test for both at the same time. And you can save time and save money. And again, we'll talk about that in a little bit. But when we talk about quality testing, we're looking for functional correctness. Does the application do what it's intended to do? When we do security testing, or when I do security testing, I'm trying to see if I can make the application do something it's not supposed to. Can I do what's called privilege escalation? Can I force the application to give me something it wasn't meant to give me? Can I force it to give me credit card information? Can I force it to give me the latest, greatest Angry Birds bombs? A variety of different things actually happen with quality and security, but again, let's do them together to optimize time. And that's what we mean by sign-off. Technology, methodology, people, process, technology. When we talk about software, when we talk about Synopsys' software capability, we're talking about that static analysis, that protocol fuzzing, the software compositional analysis, interactive application security testing, and test optimization. When we talk about the methodologies, we're talking about you all. So what we want to teach you today is actually how to use both together. So when we look actually at the Integrity platform, again, I've listed actually the different products that we have as a part of this overall platform. We're going to talk actually primarily about Covariance static analysis, because this is the easiest way to find the security defects that are going to cause problems for you. As we move forward, you might actually be interested in Defensics, which is actually called protocol fuzzing. That's when we look at the overall system of that application as it's actually configured. So for instance, an Apple iOS device, we might actually test the application for Bluetooth vulnerabilities. See if we can actually hack it via Bluetooth. We might actually test it via SIP, because we're actually using IP on phones now, or telephone IP on phones now. You might, or you should be really interested in Protocode, which Protocode finds the application that you're going to build in and looks at security vulnerabilities and licensing vulnerabilities for that. You might actually be building a web application that connects via browser or connects actually via a mobile device. You might use interactive application security testing on that. And lastly, you might actually say, I've been testing this application via system or unit testing, and my test harness actually takes 6 weeks to get through. Maybe I need to optimize that. You might actually take a look at Test Advisor. But again, we have an overall platform for testing applications, and we integrate in that platform into your existing workflow. So defect tracking, bug tracking, reporting capability. The whole idea behind all of this is let's actually work within your process and use your tools instead of actually making you go out of band and using something that you don't want to. So again, today we're going to focus on Covariance static analysis, and I promise I'll actually show you some security defects. So Covariance static analysis is considered to be the gold standard, actually, of static analysis. We find critical security and quality defects in less time than our competition. And when we find a defect, we actually tell you how to fix it. And that is the key to any single one of our technologies, is that when you find a defect, you're a part of the problem. When you help actually fix a defect, you're a part of the solution. And that is our goal. So we're going to actually talk about, again, Covariance static analysis. And the first thing that you need to understand is that Covariance has full path analysis. When we talk about full path analysis, we're actually talking about the code that you meant to run, as well as the code that you did not mean to run. So when we analyze an application, we see every decision that that application can make. In green, we're showing all the stuff that you actually meant to do. Here's a conditional actually going to memory allocation that works into conditional number 2 that gets into a freeze state. On the right-hand side of the stage, that's the stuff that you didn't mean to operate. but it's still there actually within your application. So when we talk about full path analysis, we analyze both sides. Because at some point, conditional 1 actually may do something that you didn't intend, and I may be able to take advantage of it. And again, we'll have questions at the end, but please start thinking about it. So the other thing that you need to think about is that when Covarity actually finds defects, we focus on the things that really matter. When you actually run a static analysis program for the first time, you may find a lot of stuff that you just don't care about. It's not actually meaningful. So Covarity out of the box actually focuses on the things that will either crash your application or people like me can take advantage of. So that's cross-site scripting, that's carried return line forgery injection, that's security vulnerabilities like the OWASP top 10 or the CWE SANS top 25. And those are things we'll talk about in a little bit, but I'm sure I just threw my translator for a tizzy. We also look at interprocedural analysis. So when I mean interprocedural analysis, I mean that we are tracking the process from one application to the next application, and we talk about handoffs. So in this particular file, you're looking at file-1C. Actually, by itself, has no problems, no vulnerabilities. But when file 2C actually feeds into file 1C, we have an overflow. I can actually exploit that overflow, but what we're talking about is the ability to analyze the application as it's completely put together for all data flows, how one actually feeds into the other. And this is very important when you're looking at static analysis, because if you don't have interprocedural analysis, you have false positives or you miss stuff. I said earlier, let me rephrase that. I said earlier, if you find a defect, you're a part of the problem. What we try to do is actually show you how to fix it. So when you look at a Covarity defect, and this is a snapshot actually from the tool set, the goal is within 5 to 7 minutes, you know how to fix it. This is for security and also quality defects. So ultimately, as you're looking at this, we put together the entire application to help you understand where that defect comes from, what the application is doing with that information, and ultimately how to fix it. So again, if you're not a part of the problem, you're a part of the solution. When you talk about the programming languages that you all are developing applications in, what we want you to know is that we support those. We support 90% of the programming languages out of the box. We also actually work with 90% of the compilers out of the box. We also help you with 90% of the compliance that you're looking for to prove that you're a good developer developing good code that is clean of quality and security defects. So hopefully some of you are looking at that and say, yes, I do develop in C#, because that's actually what the Unity compiler is actually built in. Yes, I do actually use the Visual Studio IDE, and we have plugins actually for that. And yes, I do care about an ISO standard or the OWASP top 10 because I'm developing a web application, or I'm developing a client-server application, and I need to look at the CWE SANS top 25. Lastly, when you actually look at how to use Covarity, Covarity can very simply be a button in your IDE. A lot of picture taking, I appreciate that. So when you're sitting in your IDE, you may actually turn around and say, I've written 6 lines of code. I need to test it actually for my company or my organization's policies. I click the button, I get up, I grab a cup of coffee or tea, I come back, and I look at my IDE, and my IDE actually says that there are 2 things that I need to fix before I can go live. And that is ultimately actually what Covarity means to you, is that you get to do your job better, faster, more efficient. So why do we do all of this? Here's actually where it gets to be really kind of fun, and I'm going to simplify this a little bit, is that as you actually get through this whole entire cycle, and up top we're actually talking those arrows actually in repeating format. So you may develop an application, you may develop 5 lines of code, you send it off to QA testing. QA testing finds 3 things. They send it back to you to fix those 3 things. You fix those 3 things. It then goes to the next step of the automated testing, where actually they stand it up and start doing system and unit testing. They may find 3 things. They send it back to you to fix it. 25 days have gone by. You're now actually working on something. They ask you to actually fix these defects. You don't even remember the code. I know, I've been there. So what happens is, as we actually get into this overall cycle that takes days and then months and then sometimes years, it gets really costly to actually fix a defect. When we look at some of the exploits in the marketplace today, World of Warcraft, Blizzard actually had an exploit that cost them $1 million to fix because it got to production. And if you were to ask Blizzard how long it actually takes them to fix defects, they would tell you that sometimes it's months. They would tell you that they have to take down their whole entire online gaming system, 6 million subscribers, for 10 hours or more, sometimes every Tuesday, to fix defects. That costs them money that they could actually probably use. So, and also, of course, the longer time you go, the more expensive it gets to fix and the number of people that are involved. Instead of one person, it might be 10. You can't actually always find the defect. That could actually be an uncommon type of problem. Documentation and tracking becomes really difficult. There's no context for the developer anymore. So when we start looking actually at testing and we start looking at these more evolved, stretched out testing methodologies, it gets really expensive really fast. Again, we have that same sort of loop actually going back and forth where it takes time. And now we start actually looking at how to find a defect. So when you start looking at system and unit testing, for instance, to find these things, oftentimes they miss them entirely because the path is gone. Nobody can reproduce actually how to find this defect. We don't understand the edge cases that are involved anymore because, again, more time has elapsed. Industry records show that if you wait 90 days or more, the developers pretty much lost the application context. They don't actually know what it looks like. They have to go back through the records. And how many people actually have seen and read development notes? And not very many. So the likelihood of finding a bug actually decreases. The cost of that bug increases exponentially. So what we want to do is help you find those defects and those bugs earlier and often and help you fix them to reduce the overall cost of a bug, actually a quality bug, from $650+ to pennies on the dollar, and actually get that bottom line up there. We also want to help you produce applications faster, get it out the door faster, which means actually the marketing folks next door that they have more time to market, more time in the market, and they can make more money from it. Same time, we also want to reduce the overall impact of customer availability and increase their satisfaction. Imagine, like I said, if World of Warcraft was available every Tuesday for that 10 hours. Now, what we also want to say to you is that it's not any different actually for a security defect. The way that we actually fix a security defect is the same way that we fix a quality defect. There's no difference. The developer has to look at it, figure out how to fix it, fix that, put it in a patch, or put it in the next revision, and move forward. Now, what gets interesting, though, is the people that typically find those defects actually on a security team are typically not involved in the fix of that. So people don't call me to actually fix a security defect that I found. And they may actually try to fix it 6 months after I found it. Security is also very difficult to quantify. How do we know the cost of security until the organization is breached? How do we know the cost of security until somebody takes down one of your Unity games? So it's difficult to quantify, it's difficult to identify. So if you make it a part of your overall process, you don't have to do that. Life becomes a little simpler. One of the things to really focus on is best industry practices, because what we see in our 1,400 plus customers is that somebody may turn around and decide to do a secure development lifecycle, and then they find out that they can only do a part of it. We find this is actually very common. So one of the things that we want to do is actually work within your process, help you understand, and help you actually scale and build this process a little bit better. So this is where we should be putting in code assurance. Start looking actually for quality defects. Reduce that overall back and forth. 1 arrow replaces 5. In a development methodology, 5 arrows there could be 90 days worth of work. We want to include security into that. Reduce that cycle down by twice. Meaning instead of actually doing it 5 arrows once for quality, 5 arrows again for security, do them at the same time and do them once, actually with one process instead of 5. You now just saved 180 days. What we get at actually when we start talking about the technology itself is a heat map. What you're looking at is a group of applications that have a policy applied to them of when they can go live. You see that some of these are actually in red. This one would not go to production. You can't release it to your customers because it has defects within it that somebody like me could take advantage of. This one over here, actually in yellow, is dangerous. It's at risk of not being able to go live. And you can see them in multiple different ways, policies in different ways, and look at overall applications. Because I'm pretty sure that each one of you actually may develop one application or one module, and that module may go to 300 different products. Well, you can find and identify that risk in those 300 products plus. So that's high level. Let's start taking it down a little bit and getting into some of the technology. So what you have, actually in Covariance, is a platform based upon the build server and the IDE. Those should be tools that you already have. So the build server actually builds in that build process, the analysis process, and a commit process to actually find quality and security defects. Once that build server process happens, you can then start looking at the IDE. And in your own Visual Studio 2015 or what have you, you can find security and quality defects as you develop them. And we actually have plugins for like Eclipse and MSVC, and we actually have command line prompt analysis if you're that kind of person where you want to actually get into the nitty-gritty. But hopefully what you can see here is that we wrap your build process and how you develop applications to understand security and quality defects, and we can integrate into your existing processes like Eclipse and Visual Studio and Jenkins, etc. I guess I went a little bit fast. So we promised that we would actually give you batteries. We have 200 batteries available. We scanned you actually on the way in. So if you get a notification from us, we will actually give you one of the batteries. Lastly, comes on to that.